Hello, everyone, and welcome. I am Zoe, a member of the ICCT communications team. Thank you so much for attending today's webinar. This webinar is being recorded and will be uploaded to our YouTube channel in the coming weeks. Everyone has their microphones on mute. If you have questions, you can write them in the questions block in the control panel to the right of your screen. After the presentation, which will last about 15 minutes, we will have an additional 15 minutes to answer questions from you. Today, we're going to talk about how IMO can maximize the climate benefits of its EEDI carbon intensity standards, presented by Bryan Comer. Bryan leads our ICCT Marine program. Thank you so much for being here today, Bryan.
Thanks, Zoe. Hi, everybody. Thank you for attending this webinar. I wanted to share some results of a study that we recently published on ways to improve the IMO's energy efficiency design index. This is the regulation that controls the carbon intensity of ships that are newly built. And the timing I thought was pretty good because we have a couple of IMO meetings coming up. The one where the next phase of the energy efficiency design index is going to start to be debated is at the 79th Marine Environment Protection Committee. And that's going to be just in not next week, but the following week. So if you're an IMO delegate, then this presentation will be directly related to some of the work that you might be doing in a couple weeks. Let me just start with our key recommendation at the top, and then I'll let you know how we got there. Basically, we recommend that the International Maritime Organization should regulate all climate pollutants, not just carbon dioxide. I mentioned that next month we have MEPC 79, and we are considering how to update the EEDI under phase 4, which is yet to be developed, and it will likely cover ships that are built sometime between 2027 and 2030, depending on the ship type. The first 3 phases of the EEDI require that new ships emit less carbon dioxide over time as ships of the similar type and size, but it ignores other climate pollutants like nitrous oxide, N2O, methane, CH4, and black carbon, BC. The IMO aims to phase out greenhouse gases under its initial greenhouse gas strategy, and also to help achieve the Paris Agreement temperature goals. And so covering all greenhouse gases and black carbon, which is a climate warming particle, in the 4th phase of the EEDI and beyond, as carbon dioxide equivalents based on their global warming potential can help achieve IMO's stated climate goals. So what we did in this study. First, we estimated and then compared the attained EEDI of a large container ship and a large cruise ship using different combinations of fuels and engines. For the container ship, we looked at a low-methane-slip engine, a dual-fuel engine, a medium methane-slip engine, and then for the cruise ship, these use high methane-slip dual-fuel engines. And then we looked at if that engine were to be using heavy fuel oil, marine gas oil, LNG, liquefied natural gas, or methanol, and then compared the EEDI scores and their emissions. The next step is that we explored how amending the EEDI could affect the fuel and engine choice of a ship owner and the associated tank-to-wake and well-to-wake carbon dioxide equivalent emissions using both 100-year and 20-year global warming potentials for climate pollutants, which is something that we've urged the IMO to do, so that way don't just calculate 100-year, also calculate 20-year, because it can add some additional insights and it can also help design better regulations, which I'll show in this presentation. So as I've mentioned, the current scope of the EEDI is tank-to-wake carbon dioxide intensity. So just what's coming out of the ship, ignoring the emissions associated with producing the fuels. Option 1 that we evaluated was continue to cover tank to wake emissions, but regulate either carbon dioxide equivalent 100, which is based on the 100-year global warming potential of the climate pollutants that I mentioned, or to do it based on the 20-year global warming potential. So options 1A and 1B. Option 2, we looked at what if IMO were to regulate well-to-wake emissions using the EEDI framework. Same time frames, 100-year and 20-year global warming potential. I'll tell you now that we ended up recommending to not regulate well-to-wake emissions under the EEDI, even though it's really important to regulate well-to-wake emissions under some regulation, one or more. And so I'll get into that. So here's the current scope. So this is looking at the fuels that would pass EEDI's phase 3 standards for a large container ship, which is the left and the middle panel, and then for a large cruise ship on the right-hand panel. Heavy fuel oil and marine gas oil are above the required EEDI, the purple bar, and you need to be below it. So, excuse me. So those fail. One moment. So conventional fuels, HFO and MGO fail. So that means that if you're a ship owner and you're building a new mega container ship, mega cruise ship, your only option really right now to comply is use LNG if you want to continue to use the same size engine that you would typically use in that ship. The other option that we're seeing today is methanol, and you can see that it just barely complies with EEDI phase 3, but it complies without changing anything. Keep the same engine type and size. And so that's why we are seeing some of the large container ships, including those from Maersk and actually a couple other companies that are using methanol as a fuel. Maersk is aiming to fuel those ships with green methanol, but even if it were to be fueled with fossil methanol, they would still, they'll pass the EEDI. And of course, the EEDI doesn't really, since it's just tank to wake emissions, it doesn't know the difference between gray methanol made from fossil fuels or green methanol made from renewables. So under the current scope of the EEDI, LNG passes, methanol passes, HFO and MGO fail. So what if we were to make some changes? Option 1A, tank to wake carbon dioxide equivalent using 100-year global warming potentials for methane, nitrous oxide, and black carbon. The bars are showing LNG, and the different colors in the bars are the contributions from the different pollutants. And so the largest portion of the bar for the LNG component is CO2, the blue portion, but then the orange portion is methane. And this shows you the difference in methane slip across those engines. So the low methane slip engine on the left, very small bar, medium methane slip, then high methane slip. And there's very low emissions of both nitrous oxide and black carbon from LNG fueled ships, so they barely register. The real difference here is how the carbon dioxide equivalent emissions change based on how much methane is slipping from the engine. In this case, LNG would pass using both a low methane slip engine, left panel, and a medium methane slip engine, middle panel, but it would fail using a high methane slip engine, which you see on the right-hand panel. The bar is above the purple line. That's failing. Methanol is shown by the gray dots, and those all pass. Those are all under the purple line. That's the tank to wake carbon dioxide equivalent emissions for methanol. So the ship owner's choice would be use a low or a medium methane slip engine, but not a high methane slip engine. Option 1B, tank to wake carbon dioxide equivalents based on the 20-year global warming potential of these climate pollutants. The 20-year global warming potential of methane, according to the IPCC's 6th assessment report, is 82.5 times stronger than carbon dioxide, whereas its 100-year global warming potential is about 30. So you can see the larger contribution to carbon dioxide equivalent emissions if we're looking at a 20-year horizon. And 20 years actually makes sense for methane because its atmospheric lifetime is only 10 to 12 years. So it doesn't really make sense to stretch out its warming impacts over a 100-year period if it's not contributing, if it's not in the atmosphere doing any warming for 80 or 90 of those years. In this case, only the low methane slip engine would pass if you want to use LNG. Otherwise, the medium methane slip and high methane slip engines have high enough methane slip, and the global warming potential of methane is high enough such that it fails. Methanol passes in all cases. So your choices then are, if you really want to use LNG, you have to use a low methane slip engine, or you can use methanol. This is the option that we recommend because it encourages only the best-in-class technology for using LNG in a marine engine, or the use of methanol. Let me focus your attention just on the right-hand cluster of bars in both of these charts. The left-hand side is showing tank-to-wake emissions, and the right-hand side is showing well-to-wake emissions. So what we did was we looked at all of the LNG-fueled ships in the entire global fleet in 2019, and we estimated their tank-to-wake and well-to-wake carbon dioxide and carbon dioxide equivalent emissions based on 100-year and 20-year global warming potential. So the bars that are labeled LNG are the actual estimated 2019 emissions in million tons for the LNG fueled fleet in 2019, according to our systematic assessment of vessel emissions model. The bars labeled methanol, MEOH, look at what the emissions would have been if those ships were instead fueled with methanol instead of LNG. And then the bars themselves show you that the most popular LNG engine, the one that contributes the most to emissions, is LPDF 4-stroke. LPDF 4-stroke is the high methane slip engine. The green bar is the low methane slip engine, HPDF, high pressure dual fuel, and then the yellow is the medium methane slip engine. So if all of the ships using LNG in 2019 had used methanol instead, their emissions would have been lower on a tank-to-wake or well-to-wake basis by more than a third. If you're looking at the 20-year global warming potential, it would still be lower even using 100-year, even though the carbon dioxide emissions are higher using methanol. And the difference is the methane slip from the LNG engines. So I mentioned that we were not going to recommend regulating well-to-wake emissions under the EEDI. And that's due to the variability in the well-to-tank emissions. So these are the upstream emissions associated with making the fuel. They vary based on the fuel's feedstock and also how it was produced, even for the same kind of fuel. So the source of the fuel really matters. And the EEDI is a design standard. So it's looking at the ship before it even has any, before it's even operating, and then certifying it to a certain standard. whereas the ship itself is going to maybe use different kinds of fuels. If it has a dual fuel engine, it might use marine gas oil at sometimes, it might use LNG at some time. And then also, even for an individual fuel, it might fuel in Fujairah at one time, Rotterdam at another time, and the fuel supplier is going to be different, and the upstream well-to-tank emissions of that fuel for each batch is going to be different potentially. And this range of well-to-tank emissions can mean the difference between passing or failing the EEDI. So that's why we don't recommend that the EEDI tackle well to wake. It should focus just on tank to wake. But if we do that, it has to be paired with other regulations that strongly regulate well to wake emissions, because otherwise you could have a situation where a ship is certified to zero tank to wake emissions. Say it was fueled with hydrogen, for instance. But if the hydrogen is made from natural gas, then its total well to wake emissions could be worse than the fuel that it's replacing. So that's why it's really important, and something that I want to emphasize is that if we stick to tank to wake emissions under the EEDI, which is what I would recommend, then we need to have regulations that also strongly control the well to wake emissions. We have a couple options. There is one regulation that is going to go into effect in 2023, so in a few weeks, called the Carbon Intensity Indicator. It ranks ships based on their operational carbon dioxide intensity, based on the mix of fuels that they've used over the course of the previous year, as reported to the IMO's data collection system, where ships are reporting their fuel consumption and activity. That gives you enough to calculate that metric. CO2 per deadweight ton nautical mile is the metric. That could be amended in order to cover well to wake carbon dioxide equivalent emissions, and you could report both CO2 E100 and CO2 E20, and we could analyze what the implications would be of giving a grade based on either one of those metrics. And then of course the CII itself needs to be given some more teeth, because right now the consequences for getting a failing grade on the CII are to make plan of corrective actions. But there's never a time where your environmental certificate is revoked, and never a time where the ship is prevented legally from sailing. Whereas the EEDI, if you don't pass the EEDI, you can't sail. We could also have a low greenhouse gas fuel standard. This is something that's being proposed and being debated right now as what the IMO would call a midterm measure. These are measures that the IMO is looking to develop between 2023 and 2030. But the momentum seems to be to try and wrap this up soon, maybe as early as next year or 2024, and then get it implemented in 2025 or 2026. And this would regulate the greenhouse gas intensity of the fuel mix of an individual ship for that particular year. And then what about existing ships? So the EEDI regulates just new ships. We also have another regulation going into effect. It really starts in 2023, and it's called the Existing Ship Energy Efficiency Index, EEXI instead of EEDI. It also regulates the tank to wake carbon dioxide emissions of the ship as a design standard, same as the EEDI. So it really applies the EEDI concept to the existing fleet. And then I already mentioned the carbon intensity indicator. Both are up for revision by no later than the 1st of January 2026. And the EEXI could be amended to cover tank to wake carbon dioxide equivalents based on 20-year global warming potential, as we're recommending for the EEDI in phase 4. And the CII could cover well to wake emissions because it actually looks at the source of the fuel. You know where the fuel came from, and you can estimate its life cycle emissions because you're looking backwards at what the ship actually used, not one on what it's designed to use. So I have 3 more slides for you. The first one sums up our view on new ships based on the study. I mentioned that IMO delegates are considering how to update the EEDI for phase 4 and that it regulates tank to wake carbon dioxide intensity of new ships. This rewards the use of LNG no matter the engine type, even in high methane slip engines, and that's contrary to meeting climate goals. It's contrary to global goals to reduce methane emissions because LNG fueled ships are a new and growing source of methane pollution. And so if LNG is going to be used, then it ought to be used in the engine that has the lowest methane slip. We showed that EEDI could be amended to cover CO2 E20 beginning in phase 4, and this would encourage the use of low methane slip engines or methanol. And just a note for those of you who are IMO delegates, there's a document submitted to MEPC, submitted by WWF, Pacific Environment and Clean Shipping Coalition, that proposes just this. Proposes that IMO agree to regulate tank-to-wake carbon dioxide equivalent emissions using a 20-year global warming potential in phase 4. They cite this study that I just presented on, and they propose to establish a correspondence group to develop the method, which probably would be based on the outcome of IMO's life cycle assessment guidelines, which are currently being developed, and also a timeline for doing so. So when is EEDI phase 4 going to apply, to what ship types, and then what's the metric going to be? Is it going to be just CO2? Is it going to be carbon dioxide equivalent using 100-year? Is it going to be based on 20-year global warming potential? Or are we going to have some sort of phase within a phase where we start with one metric and move to the next? I think no matter what, though, we need to get away from just CO2 in phase 4. It needs to at least be carbon dioxide equivalent. And that's because we need to start accounting for methane, nitrous oxide, which will be important when ships start burning ammonia, and then black carbon, which has been on the agenda for IMO to regulate for more than a decade now. So I think that would be important. For existing ships, the EEXI and CII could be amended to cover tank-to-wake and well-to-wake carbon dioxide equivalent emissions, respectively, in the 2026 review, and a low greenhouse gas fuel standard to cover well-to-wake. Final thoughts. I just mentioned IMO needs to regulate carbon dioxide equivalents rather than CO2. This will help because limiting warming to no more than 1.5 degrees requires deep and immediate cuts in methane and black carbon according to the IPCC, and regulating based on 20-year global warming potentials would encourage the use of fuels in engines with low methane emissions and low black carbon emissions. And then here's a link to the study, and then my email if you have questions, and then I'm happy to take your questions. And apologies for going long. I had it in my head, even though Zoe introduced this as a half-hour webinar, that we were going for an hour. So if Zoe's cool with it and we have questions, I'm happy to stay a little longer. Thanks, and back over to you, Zoe.
No problem, Brian. Thank you. And we can take a couple extra minutes as long as folks have questions. So get started. We'll get going. Here's the first one. Why is it so important to regulate CO2 equivalents and not just CO2, given that we're supposed to be transitioning to zero emission vessels?
Yeah, so there's this overall goal to move us from fossil fueled ships to zero emission vessels. And then the key question is what qualifies as a zero emission vessel. And so some IMO delegates are calling for zero carbon, or which could be zero carbon dioxide, but that's not really zero emission because, as I showed, Methane is a pollutant that we really have to worry about for LNG fueled ships. Nitrous oxide is going to be a pollutant that we're going to worry about for ammonia fueled ships. And so if we only continue to look just at carbon dioxide, it's going to reward the use of fuels that may have low or even zero carbon emissions. Like ammonia has zero carbon in it, just nitrogen and hydrogen, but it could have significant overall carbon dioxide equivalent emissions, greenhouse gas emissions that we're trying to regulate. So really, we need to start taking a more holistic view on climate pollution, not just gases, but also particles in the form of black carbon, and stop just regulating one pollutant by one pollutant. Get away from just, okay, we're going to regulate sulfur oxides and then nitrogen oxides and then carbon dioxide. We need to look at the broader view of marine pollution in general.
Great, thank you. Just a reminder to everybody on the line, if you have any questions, you can put them in the question box in the control panel. On to our next one here. How does the enforcement mechanism work to ensure compliance with EEDI and IMO CO2 rules?
So the compliance for EEDI, and this is also true for the EEXI, which applies the EEDI concept to the existing ships, is that the ship is inspected and certified before it even sails. So based on the engine size, the engine size basically, and then what kind of fuel you're aiming to use, how big the ship is, how fast the ship can go, and it'll get one baseline score, and then that's certified in a sea trial. And as long as you are below that purple line that I was showing, which is established in the regulations under the International Convention for the Prevention of Pollution from Ships, which we shorthand to MARPOL. As long as you're below that line, then you're certified to sail and you're good to go.
Great, thanks. Next one here is, do biodiesel and renewable diesel blends with HFO MGO pass phase 3?
No. If the this is the difference between looking at the tank to wake perspective and the well to wake perspective. On a tank to wake basis, if the fuel is chemically the same as the fossil fuel, then all we're looking at is when you burn it, how much carbon dioxide are you emitting? That's literally all we're looking at. And so as long as the fuel ends up being the same fuel in the fuel tank, even if it's made from a waste biosource that we would consider to have low life cycle emissions, then it still gets treated as the same as the fossil fuel. So that's why it's important that we also have regulations that reward the use of those types of blends, because I think it's a good thought to start thinking about blends, because I do think that's the way it's going to really start, is that we're going to start blending in some of these new fuels with the fossil fuels and trying to get credit for whatever proportion we've blended in. And that can only really happen if we have other regulations that look at the actual fuel used, not just the design of the ship itself.
Kind of tying into that, and there might not be one perfect answer for this question, but what is the best fuel of the moment?
The best fuel of the moment, I guess it depends on what criteria you're looking at. Well, I mean, I can tell you what fuels don't work. Maybe I can start there.
Sure.
We've been using heavy fuel oil in this sector for many decades now, and we thought we were going to get away from it in 2020 when we tightened the sulfur cap. But what ended up happening is that there was a loophole written into the IMO regulations intentionally to be able to use sulfur scrubbers, so that way ships are able to spend a pretty modest amount when you look at the fuel savings to install a sulfur scrubber that removes sulfur from the exhaust It allows the ships to continue to use the cheap heavy fuel oil, and then what's captured in the scrubber is discharged overboard, and that includes oil. It includes polycyclic aromatic hydrocarbons, which are carcinogen. It includes heavy metals. These things have been linked to cancers and reproductive dysfunction in marine mammals, including orcas. And then also it's acidic, and so it's contributing to ocean acidification. But then also, if you think about where ships are going, cruise ships, for instance, go to beautiful areas that have coral reefs. Well, cruise ships are the main uptaker of scrubbers, and so they're discharging acids onto areas that have coral reefs that are already suffering from ocean acidification. So you can sort of figure out that fuel is not the best fuel. Of the conventional fuels we have now, a better option is marine gas oil. That's a low sulfur fuel. You don't need to scrub it. You don't have the water pollution issue. If you're going to use LNG, it has to be in a low methane slip engine, but I would really caution against calling that a good fuel because of there's other sources of methane, including on board the ship. You're going to have methane leaking from the fuel tanks, and you're going to have methane leaking from the cargo tanks if it's a LNG carrier. Then there's upstream methane leaks that are still probably under quantified. And then there's also community impacts from drilling of oil and gas and pollution associated with that. So we're actually collaborating on a project called the Fugitive Methane Emissions from Ships, FUMES project, where we're measuring these emissions, both methane slip from the engine, but also methane leaks from cargo tanks and fuel tanks using drones and helicopters. We've been doing it all year, and we're going to publish on it next year. And so even if you have low methane emissions from the engine, the ship-wide methane emissions could still be substantial, and that's what we're looking at. Methanol can pass EEDI phase 3, and it would pass, could potentially pass phase 4 if we set the regulations at a level that it could happen. But it avoids the methane slip problem. So I think methanol makes a lot of sense. It's not a perfect fuel by any means, but of the options that we have today and that we're actually using, I would say if you're using conventional oil-based fuels, you need to be opting for marine gas oil. If you're using some of these alternative fuels and you have a choice between LNG and methanol, I'm going for methanol.
Thank you, Brian. That was such a comprehensive answer. Last question here, will the carbon intensity indicator for ships be public data?
I really want it to be. I really want it to be. So one of my roles is to serve as a technical advisor to the Pacific Environment Delegation. And then the ICCT, we're an independent research organization. So we also are advisors on the US delegation and the Brazil delegation as well. And so we've been advising that the carbon intensity indicator needs to be, those scores need to be put in a public database where anybody can look it up by the ship's IMO number, which is a unique identification number that stays with the ship even if it changes names, changes owners, changes flags, which are things that happen routinely. And so that needs to be in a public database. You need to be able to look up the ship, because the industry was arguing that if you grade us and we get a failing grade, then we're going to get punished in the market. And if we get a good score, then maybe we could get some incentives. Maybe ports will give us lower fees. Maybe we're eligible to sail certain areas. And then vice versa, if we get a failing grade, maybe ports will start penalizing us. And also, we might not be able to command the same freight rate. If you want to move something on a A graded ship, then it might cost you more than an E graded ship. That only works if it's public information. So I think, if I'm not mistaken, there's a proposal in to make the carbon intensity indicator grades public, and I think it's in from the environmental NGOs into IMO. So I welcome any support that would get, because it's only going to work if it's public. Right now, it's not written into the rule that it needs to be public, and we've been trying to get clarification on this for a couple of years now.
Right on. Thank you so much, Brian. Thank you to everybody for participating in our webinar today. And please don't hesitate to reach out to Brian or to the communications team at communications at the ICCT.org. You can send either of us an email and we'll get back to you as soon as we can. Also, remember to follow us at the ICCT on social media. And thanks again. We hope to see you soon.
Thanks, Zoe. Thanks, everybody. Bye-bye.
Bye all.